Hello and welcome back to Mr. Ali. Today I will be teaching you guys about the about applying symmetry. Now in the last lesson, lesson 81, we used symmetry to find the similarity ratios and the missing side lengths of similar polygons. In this lesson, we will basically thing. So, as you know that all regular polygons with the same number of sides are similar, because regular polygons are basically just what your everyday hexagon, your everyday square, your everyday pentagon. Those are always going to be similar. And if two polygons are similar, then their perimeters, if their perimeters, when you compare them, they will be the same as when you compare their corresponding sides. And like the example that we're gonna get to later on. And remember that all circles are similar because they're all just drawn like that, and just at that point matters about the size. And the ratio of any of circumferences of any two circles would be the same as the ratio of their radii. And here's like a little DIY, but before we move on, I just want to remind you guys to like and subscribe, so you could be kept posted on my new videos. Um, so this is an easy question. Are all isosceles triangles similar? Remember, you could always pause the video if you want to do it by yourself before I show the answers. And you could, and if you ever need help, just put it down in the comments. So over here, number one, are all isosceles triangles similar? That would be incorrect because isosceles triangles means one side is two sides are the same, but the last side is not the same. And they not all of them are similar because there could be an isosceles triangle with like the side length of 5 and then with like the base of 5, and then the two legs would be, let's say, 10 or something. They're not always going to be similar. However, with equiangular triangles, they're always just the same exact sides, the same exact length for each of the three sides, which means that the answer for one is no, and the answer for two is yes, as you can see here. And now here, example one. So let's put what we learned in the last lesson, lesson 81, into this lesson. Regular hexagons. So these are just normal everyday hexagons. And there's a smaller hexagon put into the bigger hexagon. And it's telling us that the similarity ratio is 5 to 4. And what it's trying to find there, what it's trying to get us to find is y, x, and the ratio of the perimeters. Now, one of them we can already solve without having to do anything, and that would be C. Remember, if you want to do this by yourself, always pause the video if you want. And that would be C because over here, as we said before, the ratio of the perimeters would be the same as the ratio of the corresponding sides. And here it's telling us that the ratio is 5 to 4. So for C, we can already put 5 to 4. Because whatever ratio they give for the sides is going to be the same ratio for the perimeter. And now let's go back to A. So over here it's trying to tell us that to find 2y plus 4. And since this is a regular hexagon, it means all of the sides are exactly the same. Um, so it would just be 2y plus 4 equals 20. And you just do like some, just adding and subtracting. You get 2y equals 16 and y would be 8. So your answer for A would be just 8. And now it's trying to tell us to find x. So, and now we have to find the side of the smaller hexagon. So we do 20, remember, times 4 over 5. And we would get 16. Yeah, sorry. 20 times 4 over 5, we would get 16. So we could do 1 half x minus 2 equals 16. It would be 1 half x equals 18. And then x equals 36. So you put so your answers would be a equals 8, y equals 8, x equals 36, and the ratio is 5 to 4. And let's see if we're correct. And this shows their solution. You can always just take the time to see this by yourself. And yeah, that would be the answer. Here's the second example. Um, Figures A, B, C, D, E, and K, L, M, N, O are similar pentagons. And remember, a good way to always start out your problems is by making like a little sketch of both shapes. So you could like kind of visualize the problem, because I know that's always helped me. And it's telling us that their corresponding sides have a ratio of 5 to 6. The perimeter of KLM and O is 24 inches. What is the perimeter of pentagon ABCDE? What we would do here is just 24, 24 times 5 over 6, and we would get 20. So because what we would do here, we would use the similarity ratio given to us here, and since KLMNO has the value of 6, because remember in the last video we said the numbers correspond to which order the shapes are put in. So KLMNO its ratio is 6. So we would just do what times 6 would be 24, and that would be 4. So 5 times 4 would be 20, and or you could just do 24 times 5 over 6, which is just rewriting this um uh, the similarity ratio as we said in the last video. We could always write it as a fraction or with the colon. And let's see if we're correct. Yeah, the perimeter is 20 inches. Here's the third example. The ratio of radius of circle A to the radius of circle B is 3 to 2. Find the circumference of circle B if the circumference of circle A is 15 inches. Now remember in the a few minutes ago we said that all circles are similar, and the ratio of the circumference is the same as the ratio of the radii. So what we would do, just like in the previous problem, we would do what's given to us times the ratio. So it's telling us that the ratio of circle A is 3 and the ratio of circle B is 2. Um, so we would do, there's two ways. First way is we could do 15 times 2 over 3. We're just reworking the similarity ratio to make it into a fraction so we could multiply. 15 times 2 over 3, we would get 10 inches. So the circumference of circle B would be 10 inches. Or we could do what times 3 would get you 15? That would be 5. So you'd do 2 times 5, and you would get 10 inches. And that's correct. Thank you for watching today's video. I know I haven't posted in a while, but I'll keep you posted. Just subscribe so you'll be kept posted on all my videos. And remember, hit that like button, and I'll see you guys later.